SWS Panel and Truss, in association with RIVANTE Design and CAD Services, is recognized as the most advanced and complete panel and truss system available today. For that reason, our company was chosen by the U.S. Department of Housing and Urban Development, the State of California Seismic Safety Commission, UCSD, Worcester Polytechnic Institute, and other industry leaders such as Sherboard, USG, and Semco, and others, to fabricate and build the first 6-story, all-light gauge steel building to undergo the highest seismic testing to date at the UCSD Seismic Testing Table in San Diego, California. Just to give you some perspective, please witness the comparison of a 4-story wood building being tested at 7.2 seismic episode alongside the 6-story SWS panel building being tested at 10.05. Which building would you rather be in when the next earthquake hits? Our mission statement is to use the latest technology to maximize efficiency and finish your project faster, with less change orders, complete your project with lower operating cost, and get you to revenue faster. SWS Panel and Truss is located about 11 miles south of downtown Los Angeles in the city of Southgate. We have 100,000 square feet of manufacturing under roof and over 120,000 square foot of storage and yard space. We have full roll forming capabilities and can produce track, studs, joist, and truss components through our 5 roll formers, which are fully IAPMO approved for anywhere in the world. These roll formers allow us to create any shape from 1.5 to 12 inches and can roll from 14 to 20 gauge. With our brake press and shears, we can even produce all of our own clips, angles, ridge metal, valley metal, fascia, CRC channel, and much more. We have 5 fully automated wall assembly tables, 10 floor framing tables, 2 large truss assembly tables, 2 automated screw bridge lines, 3 overhead cranes, a 17-ton brake press, multiple shears, full welding department, and in-house trucking, trailers, and delivery system. The SWS wall panel production tables assembles the wall panels under compression and automatically screws both sides of the wall at the same time. No flipping needed. SWS floor panels come complete with the decking, hoisting clips, and crush blocks or flush beams already installed in the panels and ready for installation. In fact, the average time to install a floor panel, which many times is a complete unit, is 12 to 14 minutes. Imagine joisting an entire unit in the field and screwing down the decking with blocking in 14 minutes. Our automated screw bridge system screws off a 20-foot wall panel in about 4 to 5 minutes with perfect uniform precision. What used to take 5 to 10 men 45 minutes to complete now takes only 5 minutes with only 2 men. SWS truss fabrication starts with our proprietary software that calculates and engineers, then creates each truss profile and load values and prepares the deferred submittals for the city. At this point, the truss material is rolled, processed for each profile. They are assembled on our process tables, marked and bundled and packaged for delivery. Each truss receives our adhesive tag that includes our QRC code for quality control and field review. Our color-coded digital mark indicates the needed number of screws at each joint and another color-coded mark as to how it is positioned on the building. Each bundle is packaged with a layout drawing indicating where each truss goes and how that particular bundle is positioned in sequence on the building. SWS has a very unique storage and delivery system. Using our proprietary computer sequencing system, we can ensure that every wall panel, floor panel, and truss arrives in a pre-approved order of installation, making sure that the field installer will never have to hunt through a bundle of panels for the next panel in sequence. SWS also labels our panels and trusses using a color code and number sequence, which can be read by anyone no matter the language spoken, which eliminates all confusion in the field. Also, our electronic QRC code allows instant verification of any wall, floor, or truss placement. The strategic alliance between SWS Panel and Truss and the RIVANTE technology has proven to increase production accuracy and minimize errors by ensuring that every stud, post, beam, and sub-penetration is exactly in the place it belongs prior to the start of construction. The proprietary BIM process is based in 3D AutoCAD and compatible with Revit, Navisworks, and Navismanage, which allows an integrated coordination with architect, engineer, and MEPF designers. Not every subcontractor or field installer is AutoCAD literate, and many would not be able to even open, view, or read an AutoCAD file if needed to verify a panel electronically. Hence, RIVANTE has developed and provides a 3D PDF process drawing that anyone can open, view, and manipulate. So when a field framer looks at his 2D drawings and needs to verify the panel or truss electronically, he simply scans the QRC code and a 3D PDF appears, hyperlinked with all the connection details at his fingertips with just a touch of the pad or smartphone. If he can operate a smartphone and open an email, he can operate this system. The SWS floor system operates just like the wall panel system, utilizing 4 hoisting clips instead of 2, making it ready to install. Whether the panel is stackable or ledger hung, the panels are complete with decking, crush blocks, blocking, and channel. Also, when our floor panel uses the new SureBoard floor system, the overhang ledger will fully support the floor system while the panel is being attached to the walls. Now this eliminates the need for any additional ledger support. Our truss system is so accurate and simple to assemble that the majority of our installers assemble the whole sections of the roof on the ground and then simply hoist the entire section into place, creating a safer environment for the field installers and also decreasing the roof installation by more than half the time. Also be aware that in most cases our trusses or framed roof system will design the slopes and the drainage crickets into the framing, eliminating the need for foam crickets and eliminates another step in the expensive roof process. In many instances, we can design the parapets and mansards directly into the trusses, also eliminating additional framing steps. As a manufacturer, SWS is well aware of the concepts of lean production and redundancy. Our team in the factory employs every effort to increase productivity through reduced motion and repetitive process. When SWS is employed to coordinate the mechanical, electrical, plumbing, and fire system in our BIM process, we try to incorporate that same lean concept in the field by creating drawings that are alike. For instance, in this plumbing drawing, the subcontractor will discover that every unit number 11, which may occur 20 times in the building, will be framed exactly the same, each time with the same penetrations, and those penetrations will be in the same location. Each time that unit number 11 repeats. Each time that subcontractor comes to the next like unit, he will be faster and more efficient in its installation. What is even more important is he can prefabricate much of his plumbing trees off-site, saving expensive field labor and saving time in the field installation. What we provide and how we provide it. By providing a more efficient BIM process and better drawings, we can disseminate more exact information to all subtrades and field installers. Our walls, floors, trusses are all properly sequenced and organized in our unique delivery system. Our in-house roll forming allows better control of our cost and more accurate cuts at every level. Our in-house truss design and engineering allows for component installation and reduced framing steps. Our pre-installed dense glass and sureboard wall reduces field installation time. Our prefabricated floor panels with decking already installed also reduces that expensive field framing time. The natural result of all of these system efficiencies are faster completion of your project, completion of your project with less change orders and less confusion in the field, a lower operating cost, less general conditions, less cost on money, and less debris haul-off. 50% reduction in your project course of construction insurance by law. So you get to revenues faster through that reduction of construction time. Seismic shear systems in a seismic zone 4 has always been an expensive and slow process in the field. SWS employs two systems that have proven to be the most effective and efficient systems available today: sureboard and special concentric brace frames. Although sureboard is extremely effective, it can also be time-consuming and difficult for inspectors to verify the uniformity of the screw patterns. At SWS, we install the sureboard mechanically with laser precision using our automated screw bridges. These automated tables cut the labor time to 10% of the field installation, and with such precision the inspectors can verify the spacing and uniformity at a glance. Field installation of the shear walls utilizing the sureboard system is as simple as the installation of any of our wall panels. With hoist clips all ready to hook onto, just lift it into place. The new sureboard floor system is also applied in the factory and is flown into place with ease and with the reduction of manpower in the field. Again, the ledger overhang allows the floor panel to seat and remain in place without the need of additional ledgers, allowing the installers easy access for attaching the panel to the wall. Another very efficient shear system is our special concentric brace frame solution. Brace frames are traditionally large frames of I-beam construction, sometimes as much as 20 feet long, and need to be individually fireproofed, an expensive and cumbersome process. However, the SWS system is quite different. Our frames are designed to take only lateral loads and do not take any vertical loads at all. Our wall panels take all the vertical loads. This allows our frames to be designed with much smaller HSS tube steel members that will fit within the wall cavity and eliminates the need for any additional fireproofing since they are not considered a primary frame. Our proprietary compression plate system designed for podium construction allows for placement anywhere in the podium and does not require the frames to be placed over a concrete shear wall. Also, sureboard is limited to 65 feet in height, which limits the building to 6 floors of light gauge steel framing. With our brace frame solution, we can technically build to 160 feet, making our system suitable for high-rise construction, such as our project in Little Tokyo in downtown LA. This project is 8 stories of light gauge steel with a pool, spa, fitness center, and promenade on the roof, effectively making it a 9-story building. Now let's take a look at a few of the SWS Panel and Truss most recent projects. Merrill Gardens Senior Living in Huntington Beach, California. This building is 3 stories, 115,000 square feet, with 105 units of assisted living and 16 units of memory care. The general contractor was SRM and the structural engineer was DCI. In these next few slides, we see the Merrill Gardens project under construction. And here, Merrill Gardens complete. Montecedro Senior Living in Altadena, California. This building was 420,000 square feet of senior living, assisted living, and memory care. The general contractor was DPR and the structural engineer was KPFF. We finished this project 4 months ahead of their schedule and saved them more than $4 million. In these next two slides, we see the Montecedro project under construction, showing walls and floors being flown into place. And here we see an aerial view of the project about halfway through construction. In this slide, we see a video taken by the contractor's drone. First, we see the main building, and then behind the main building to the north, we see two of the three villas designated for senior independent living. To the right, we're looking down on the area that's designated for the memory care units. Now remember, this project was built for the Episcopal communities, and again, due to the use of the SWS system, finished 4 months ahead of schedule, allowing the Episcopal communities 4 months of early revenue on their project. In these last two slides of the Montecedro project, we see the beautiful completed project. The Weston Desert Willow in Palm Desert, California for Starwood Hotels. We have 18 3 to 4 story buildings, each at about 44,000 square feet, 42 units each. 3 buildings have been completed and in process of the 4th. A total of 132,000 square feet to date. The general contractor is Artie Olson. The structural engineer is KPFF out of the San Diego office. In these next two slides, we see one building of the Weston Desert Willow project under construction. Wall panels being installed and floor panels being hoisted into place. The majority of the roof of the Weston was constructed on the ground, and then whole sections of the roof were hoisted into place. That makes for a much safer environment and saving considerable time in the field. They say a picture is worth 1,000 words, so a video must be worth 10,000. Here you see a time-lapse video of the Weston Desert Willow project from slab to finish. Please note that each halt of the camera represents a day. The SWS panel system lends itself well to projects in hospitality, senior housing, skilled nursing, and market rate apartments. So when it comes to student housing, we shine even brighter. SWS Panel and Truss just completed the twin towers of the SDSU South Campus Plaza, a student housing project and mixed-use facility on the campus of San Diego State University. The two 6-story buildings equaled 225,000 square feet, residential and retail. The GC was Sunt. The structural engineer was Ficadenti, Wagner, and Castle out of Irvine. Since the SDSU South Campus Plaza project exceeded 75 feet, the engineer opted to use the SWS panel braced frames for all the lateral shear. Here you see the brace frames in place and the wall panels just beginning. Here we're further along in the construction of the SDSU South Campus Plaza. The site constraints of the project were many. In fact, we had 0 area for laydown of any wall or floor panel. All deliveries to the building had to be direct from the truck to the building, and the only area for that offload was the space between the buildings. Another obstacle was the fact that the installer, Standard Drywall, had never used our system before this project. However, even with those constraints, the total light gauge steel framing of 183,000 square feet plus was completed in less than 4 months. Now that's 45,750 square feet per month, 11,438 square feet per week, and 2,286 square feet per day. How fast are your present projects being constructed? Here we see the 2 buildings of the SDSU South Campus Plaza completed, again, in just 4 months. Another one of our construction partners is the Grand Pacific Resorts in Carlsbad, California. We are presently building the Westin, Sheraton, and Hilton hotels at the Marbrisa Resort in Carlsbad, California. We're presently fabricating in excess of 225,000 square foot of building for the resort adjacent to Legoland. The GC is Grand Pacific Resorts and the structural engineer is Burkett and Wong. In these next few slides, you see the Marbrisa Resort under construction. Each of these similar buildings are being completed in about 30 days from slab to top out. In this slide, please note the construction of an entire section of roof completed on the ground and then hoisted into place on the building. The safety margins of this process should be enough to make the whole process worthwhile, but the speed it generates towards the completion of the building is amazing. Needless to say, the installers at the Marbrisa Resort truly appreciate this aspect of our system. One of the buildings at the Marbrisa Resort in Carlsbad, California, nearing completion. Quite possibly the most exciting project that the SWS team has been involved in has been the UCSD mid-rise earthquake testing in San Diego, California. Here we fabricated and constructed a 6-floor building on the UCSD seismic testing table for the U.S. Department of Housing and Urban Development, the State of California Seismic Safety Commission, UCSD, Worcester Polytech Institute, and other industry leaders. As discussed earlier, the test consisted of a series of earthquake simulations from 6.7 to 10.5 seismic episodes in an attempt to record the damage that such a seismic episode would have had on a building such as this. RIVANTE implemented a complete BIM model of the project, including the details of the foundation, which was the UCSD earthquake testing table. We then produced shop drawings for all of our walls, floors, and roof panels and shared that information with all team members in the test process prior to the construction of the building. After the approval of the BIM model and shop drawings by all the engineers and team members, SWS proceeded to fabricate and deliver the walls, floors, and roof panels to the site. A local installer spent 5 days stick framing the first floor walls. That was due to the fact that the connection to the table required that step. However, from the floor above the first floor and the next 5 stories, only took 5 days to install and finish the remaining 5 stories. One of the new products being tested on the UCSD mid-rise earthquake testing table was Shoreboard's new floor system, comprised of 9/16" Plysom cementitious board attached to 20-gauge sheet metal. The product has been fully approved through UL testing and IAPMO, but this was its first real-life seismic test. Also good to note that SWS was instrumental in helping to implement the development of this product. Now let's take a look at a couple of the actual tests that took place on our building in San Diego. First, you see one of the tests that was 150% of the Northridge earthquake of 6.7. Now that equals a 10.05 seismic episode, and that's higher than any recorded in history. After more than 10 tests at this magnitude, the table could not produce any significant damage to the building beyond a couple of cosmetic cracks in the drywall. Please note in the top view of the 1,500-pound steel plates at every unit to simulate live load. This occurred at every floor along with a fully loaded water heater, range, a complete fully loaded building. Second, they loaded the 2nd and 6th floor with accelerants and burned the building, which in itself was not easy, being that there's nothing combustible in the building, hence the accelerants. Third, after continued burning in an attempt to weaken the structure and destroy the drywall and Dens glass and Shoreboard system, they again shook the building to the maximum. Only then, after the burning and after the breakdown of the drywall and Dens glass, did the building show any true damage, but only at the second floor where the burn took place. However, the building stayed intact. It didn't collapse. It didn't lose its shape. The fully loaded building still maintained its structural integrity, which would have allowed anyone in the building to survive and walk away from the incident. Here you see the building after burning and after several more attempts to destroy it through additional shaking, and the building is intact. As a matter of fact, the SWS Panel and Truss crew had to come in and disassemble the building to bring it down. The SWS Panel and Truss team welcomes you to come down to our factory and take a tour. Remember, we are also completely made in the US of A. Thank you.